Okay, we're doing cubes and cube root functions. We've already done squares, which is quadratics, and square root functions. So now we're doing cubes and cube roots. Okay, we're doing both of them today. So our first one is the cubic parent function, which is just x cubed, so x to the third power. Now the way you type that is you have to hit this little caret top, the little arrow up. So it's just x caret top 3. Okay, so when I hit graph, this is what it looks like. I call it the swerve, and I think it just looks like a swerve in the road, right? Okay, and it's also a tall swerve, like it's tall and skinny, so tall swerve. Okay, so we're going to plot points. We're going to go to our table. And now there's no rainbow or anything like with quadratic, so I just start where I know both my x and my y are between -10 and +10, because that's all I can plot on my graph. So this first point I cannot plot because -27 is not between there, but -2, -8 can be. So -2, -8, -1, -1, 0, 0, +1, +1, and +2, 8. Well, domain, it's going to go to the left super slow, but if I continue my pattern, it's going to keep getting wider. Same with the right. It's going to keep going, it's going to keep getting wider, but it's super slow. So like if you look at these numbers, they only go up by 1, while these are going up by a whole lot. Okay, so that's why it is getting wider forever. It's just super slow. So this is -infinity, +infinity, or all real numbers. And then range-wise, it goes down forever and it goes up forever, and we see that. Okay, so the range is also -infinity, +infinity. Child. Thank you. Okay, what's my vertex? Well, vertex in this is a little different. It's the middle. It's that piece where it kind of changes direction. So see how it's coming up and it's starting to curve to the right, and then all of a sudden it curves up? That piece in the middle is your vertex. So here it is 0, 0. Which is also my x-intercept and y-intercept. Now, are those points, the vertex, x-intercept, and y-intercept, always going to be the same? No, only for the parent function. Now, is this graph increasing from left to right or decreasing from left to right? Increasing. And that's what we know. Okay, a couple things we need to know. Things we need to remember are, what other words for x-intercepts? Do y'all remember any? Roots. What's the other one? Starts with a Z. Zeros. Both of these can be asked for, and all it means is x-intercept. Yes? Yes. So your x-intercept is where y equals 0, and your y-intercept is where x equals 0. Don't forget those things. And then just a reminder, your vertex is where it switches places, or switches directions. Any questions with our cubic parent function? Okay, so now let's look at our cube root parent function. So to do a cube root, you have to hit math 4. So math 4. Okay, I'm going to go to my table. Now this is kind of like square root when you have all those ugly decimals, but we're only plotting pretty points. So if we go up towards -10, I'm going to plot my first pretty point, which is -8, -2. Math 4. Then we have -1, -1. 0, 0, 1, 1, and then 8, 2. What do you notice about the two graphs? they're the same shape, just different direction, okay? So this is a swerve as well. It's just a wide swerve, okay? Now, one thing I like to say is that whenever you're trying to figure out your equations and you're trying to decipher between the two, this is a cube root, right? Isn't this kind of the shape of a root? Do y'all see what I'm saying? Okay, that's how you know. So if it's wide, it's kind of the shape of a root, and that's how you know it's a root, not a cube. Yes? Okay. So knowing that, domain and range, well, same thing. It goes left forever, goes right forever. We know that. This is all real numbers. Does it keep going down and up, just super slow? Yes. So my range is also negative infinity, positive infinity. So if you notice, domain and range for both are always all real numbers, negative infinity, positive infinity. My vertex is still 0, 0, because that's where it changed directions. My x-intercept and y-intercept are also 0, 0, and again, those will not always match. Now from left to right, is it increasing or decreasing? Increasing. Any questions with that? Okay, so let's look at our cube root examples first. So we're going to look at number 1 and number 3. So look in here, before we even write anything down, before we keep going, I want you to realize that A is still the same thing. A makes our vertical reflections, or reflections over the x-axis. Reflection. Why did I spell that wrong? Okay, you get what I'm saying. Okay, it also does a vertical compression or a vertical expansion. And it's your first change, which I'll show you what I mean in just a second. It's your first change. Now, H comma K is your vertex. H is your X, K is your Y. And I want you to remember H is opposite because that's your inside change. And the K is exact because that's your outside change. Because do you notice these look almost exactly the same as the quadratic and the square root? They just have the 3 instead. Okay? So knowing that, let's look at number 1. Okay, what transformations is this going to take without even graphing it? What do we know? Right 2 up 3. It has no number in front, so nothing is changing with your A. So that means my vertex is the opposite of the inside. Was the opposite of negative 2? Exact outside. So there's my vertex. Didn't even have to graph it, and I know it. Okay. What did we say domain and range is always for these?
Negative, infinity, positive.
All real numbers, negative infinity, positive infinity. And A is positive, so is this increasing or decreasing? Now, x-intercept and y-intercept you can't find without typing it in. So we're going to type it in. We have math 4, x minus 2. Come outside the house and put plus 3. Okay, I'm going to find my points that I can plot, starting with negative 10 for x. So my first point is negative 6, positive 1. Then I have 3 points, so 1, 2, 2, 3, 3, 4. And then keep scrolling, and I have 10, 5. Now, my intercepts are not pretty points, or at least I can't see my x-intercept, but I can find them in my calculator. So I know my y-intercept is where x equals 0. My x-intercept is where y equals 0. So x is 0 is right up here. And it's a decimal. We're just going to round, so it's going to be 0, 1.7. Everybody okay with that? Now to find my x-intercept, I need to scroll and see if I can find where y is 0. So y is getting smaller going up, so we're going to keep scrolling up. And we're looking for where it is 0. And here it is. So negative 25, 0. Any questions with that? Okay, so I want y'all to try example 3.
When is it decreasing? It's like when it's reflection or compression.
Reflection.
What are reflection? That's all the time.
If it's going down from left to right.
What is it? Vertical compression and expansion increase, right?
They're always increasing unless it's reflected. Okay, what do you notice as with this one?
Vertical expansion.
Vertical expansion. What else?
Going down.
Down 4. Okay. What do we know about domain and range always?
Always negative, all real.
Yeah, it's all real numbers, negative infinity, positive infinity for both. What's my vertex? 0, negative 4, because there's no inside change. There's plus or minus nothing on the inside, which means 0. And my outside is exact, so negative 4. So it's 0, negative 4. And is this one increasing or decreasing? Increasing. So this is what it should look like. See how it's like taller than the original? That's how we know it's a vertical expansion as well. Any questions with this? Okay, so now let's look at our cubes. So looking at number 2. What's going to change on this one? What transformations? Left 5. Down 6. What's domain and range always for these? Cube or cube root. All real numbers, negative infinity, positive infinity. What's my vertex? Negative 5, negative 6. Increasing or decreasing? Increasing. So if I hit graph, it's increasing from left to right. It looks like it's about negative 5, negative 6. That makes sense. And so we did everything correct. So let's look at our table to find our x-intercept, y-intercept. So x-intercept is where y equals 0. Y-intercept is where x equals 0. So right here at x equals 0, we have 0, 119. So there's my y-intercept. And then you'll notice that my y should be 0 somewhere between negative 4 and negative 3. I don't see it. So we're going to plot these points, and then I'm going to show you what you can do. So negative 6, negative 7, negative 5, negative 6, negative 4, negative 5, negative 3, 2. So this is what it looks like. So you can hit graph, and we want it to calculate our x-intercept. So second, trace. See how it says calculate above trace? So we're going to click that. What's another word for x-intercepts? 0, so we can click 0. Now, my point currently is 0, 119, okay, which is way up here, right? So I'm going to scroll down, or left, sorry, because it says left bound. So look, there's my cursor. You see my cursor? I want it to be on the left of the x-intercept. So right now, it's on the left of the x-intercept. I press enter. Now it says right bound, so I need to move to the right side of my x-intercept. Press 0. Then it says guess. We don't want to guess, so we're going to press enter one more time. And there's my 0. So it is negative 3.2 comma 0. Now, if it was multiple choice, and there was only one answer between negative 3 and negative 4, could you pick that one?
Yeah.
Yes. Now, one thing I want to talk about too really fast is, remember when I said it's your first change? Do you notice that, like on this one, from vertex, when I say first change, so let's start with your vertex. So my vertex is here. So from this point to this point, what changed? From here to here. Didn't it go up 1 over 1?
Yes.
So A is 1. Is it okay if I put a 1 there?
Mm-hmm.
Did I change anything?
No.
No. What happened on this one? From vertex to the next point to the right. Didn't it go up 2 over 1? What's your A?
2.
Do you see what I'm saying as first change? Here, my vertex is here. It went up 1 over 1, so A is 1, which I did not have to put. You don't have to put a 1. Does that make sense? Okay, so I want y'all to try example 4. Okay, what changed on this graph?
Reflection.
Vertical reflection, or reflection over the x-axis. What else?
Left 2.
Left 2,
Up 4.
up 4. Everybody okay with that? Okay, what's domain and range?
Negative 3.
Negative infinity, positive infinity, all real numbers. What's my vertex of this one?
Negative 2.
Okay, and is it increasing or decreasing?
Decreasing.
How do I know it's decreasing?
Because the reflection.
The negative. Okay, A is negative. That's how I know it's decreasing, or I graphed it and it's decreasing. Yes? From left to right, see how it's going down? When you're done writing that down, I want you to flip to the practice because I want to show you something. Look at number 5 and number 6. Okay, I'll put it back in just a second. Look at number 5 and number 6. Well, first off, is this one a square, a cube root, or a cube? It's a cube root. Remember, it's when it's long, it looks like a cube. So this is y equals, I'm going to leave a space for A and put a cube root. What about this one? Number 6. It's tall and skinny. Okay, so this is a cube. So I'm going to leave a space and I'll put a cube. Now, here, remember, A is your first change. So from vertex to my next point, what changes? It went up 2 over 1. So what's A? 2. Look at this one. What changed? It went down 1 over 1. So what is it? Negative. Do I have to put the 1? No. Do y'all see what I'm saying about A? Okay, what's my vertex on number 5? No. 3, 0. So X always goes right here. And it's opposite of the x value of my vertex. What's the opposite of 3? And then do I have to put plus 0 on the outside? No. Could I check this in my y equals and make sure those points are in my table? Yes. Okay, and now it says solution f of x equals 2. Y'all, f of x means y. Where does y equal 2? Well, here's y is 2. What's the height of that graph? Or where is that? X equals 4. Okay. Any questions on what this is looking for?
Can you do number 6 real quick?
No. You could do it. One other thing, and then I'll flip right back to this, is on number 10 and 11, this is a formatting error. Do you see how the points are not on the line? The line is correct, the points are not. They're a little high. So if you just bring this one down, this point, they should be pretty points. Yes? I don't know what happened in my formatting, but that's the points. Does that make sense? So just don't stress out about those being decimals. They're not. That was a formatting error. Okay, so this is what you're working on. If you finish, which you have time, but if you don't finish, that's fine. You should get close to finish and then be able to finish tomorrow.